All right, so 18 wants you to list all the possible rational, okay, just the rational zeros. And remember that the rational zeros comes from taking all the factors of P and putting them over the factors of Q. And P is the constant on the end, and the factors of 8 are plus or negative 1, plus or minus 2, plus or minus 4, plus or minus 8. Sorry, I meant to put those in red. Oh well. And then the denominator comes from the 2, and those factors are either a positive or a negative 1 or a positive or negative 2. Hang on a second. I got to fix that. It's going to drive me crazy. Ah, there we go. It's in the right color now. Okay, so I'm going to start with if you put 1 over 1 or 2 over 1 or 4 over 1 or 8 over 1, that's just the same as plus or minus 1, comma, plus or minus 2, comma, plus or minus 4, comma, or plus or minus 8. But then you have to go and do, instead of 1 over 1, 2 over 1, 4 over 1, and 8 over 1, now, what color did I grab? Purple, okay. Now we're going to do 1 plus or minus 1 over plus or minus 2. So that's a plus or minus 1/2. Now when you do plus or minus 2 over plus or minus 2, that's the same thing as plus or minus 1. When you do plus or minus 4 over plus or minus 2, that's the same thing as plus or minus 2, because 4 divided by 2 is 2. And when you do 8 over 2, 8 over 2 is the same thing as 4, so it's plus or minus 4. So the only extra factor that I got, or extra zero that I got, was the plus or minus 1/2. So that is my complete list right there. And I'm done with number 18. Okay, now 19 wants you to find only the rational zeros. And they want to know what the rational zeros are. So just like before, you have to start with the whole P over Q thing. Let's see. So if I've got P over Q, my P comes from the 21. So it's either a positive or negative 1, positive or negative 3, positive or negative 7, or positive or negative 21. 1, 3, 7, and 21 are all the factors of 21, and you have to consider both positives and negatives. Now the Q comes from a 1, which means it's just positive or negative 1. But 1 over 1 or 3 over 1 or 7 over 1 or 21 over 1 is just these numbers right here. So I've got 2, 4, 6, I've got 8 possible zeros. I have no idea what they are. So I'm just going to start guessing. And I'm going to use, you can either plug and chug if you want, like do plug it in here and here and here. Whoops. Plug a 1 in here and here and here and see if it equals 0 when you do the math. Or you can do long division. If I try the positive 1, the factors are 1, negative 9, 11, and 21. And you just bring the 1 down. 1 times 1 is 1. Add that, I get negative 8. Negative 8 times 1 is negative 8. Add that, I get 3. 3 times 1 is 3, and it adds up to 24. That's not a 0. So 1 is not a factor. So then I try negative 1. 1, negative 9, 11, 21. Drop down the 1. Negative 1 times 1 is negative 1. Add that, you get negative 10. Negative 1 times negative 10 is positive 10. Add that, you get 21. 21 times negative 1 is, negative 21, and I get a 0. We have our first rational 0. Now you can keep doing this with plus or minus 3, plus or minus 7, plus or minus 21 until you find them all. Or you can say, okay, I know if negative 1 is one of my factors, then that came from an x plus 1, because you'd have to stick a negative 1 right there to make that 0. And then the other factor comes from this right here. That's going to be an x squared minus a 10x plus a 21. And then I can see if that factors. So I've got an x plus 1, and then this factors to be x minus 3 and an x minus 7. So my 3 zeros are, this was my first one, this was a negative 1. And then this one is a positive 3. And this one is a positive 7. Those are my 3 zeros. Number 20 says state the domain. Okay, this is a rational function, and the domain is when the denominator, it's any number that x can be. But because I have a rational function, my denominator of 7x plus 63 is not allowed to equal 0. So I'll subtract the 63 over and divide by 7, and x is not allowed to be a negative 9, but it can be anything else. And I do want this in interval notation, so you're going to say negative infinity up to the negative 9, but don't include it, unioned with from the other side of negative 9 to infinity. And that's the domain. And then the next one says find the vertical asymptotes. That is also when the denominator does equal 0. Whenever the denominator does equal 0, that is where the vertical asymptotes are. So I'm going to factor this, set it equal to 0. 2 factors of negative 40 that add up to negative 3 would be negative 8 and a positive 5. Now remember, vertical asymptotes are equations. So on this one, I have to say x equals 8 is one of my vertical asymptotes, and x equals a negative 5 is the other one. Remember, if you had a graph on the x-axis, here's y. Somewhere down here at 8 and down here at negative 5, there would be these imaginary lines where your graph cannot cross, and they're called asymptotes.